This is an initial build of a mutual cap sensing designed to look at the dielectric properties of oil, engine oil. You can see in this container we've got clean engine oil. We're using some strips of copper to capacitively sense the dielectric between these sensors here. So I've got one receive sensor here, I've got a guard sensor, I've got a mutual drive sensor, and you can see at the back there's a second mutual drive sensor giving me two readings between this and this sensor and this and the back sensor. Here's my board actually doing the measurements. You can see each time the LED flashes here it's reporting one set of measurements corresponding with the data input to the GUI. The readings I'm getting show very clearly whether we have an empty vessel, which is calibrated using this container. As I say, this is the board we're actually reading now. So we're reading clean oil, which is shown on here, with a value of about 400, something like that. The second sensor is showing about 250, so it shows that one technique is slightly better than the other. So probably concentrate on this technique. I thought I'd try both as I was setting up an initial experiment. This channel is a fixed capacitor I use to make a reference measurement, because I don't want to keep calibrating. I don't know the state of my oil levels or oil quality when I switch on, when I calibrate, so I need something as a reference to compare to. So I'm using fixed values, and because you can't rely on those fixed values always being consistent with the ambient conditions, temperature and other factors, noise factors, by using a capacitor I can eliminate a lot of those uncertainties, because that's what just an extra channel measurements being made on. Here are my two values, so it's probably the blue channel here, which corresponds to this particular meter reading, and over here you can see my capacitor reference. While it's somewhere in the middle, it shows that I'm operating somewhere in the right range. Ideally it would be bang in the middle for the exact value of capacitance, but you do get a lot of variation with these small caps, so it's understandable that it's moved from the one that I calibrated on. I'll change over now to the empty and the dirty oil container. We'll see what sort of effect that has on our reading, hoping that, well, obviously I know that as we move towards empty we're going to get the meter moving down to this end, and as we get dirty oil, you know, the dielectric changes and we'll see the meter moving up towards the other end, an indication to change the oil. So I've switched out the oil container. You see the good oil at the back. This is the old engine oil I managed to collect from a local garage. Exactly the same circuit board, same inputs and everything. Capacitor values roughly the same, but you can see there's a huge change up towards the dirty end, as we call it, the high reading from the dielectric change. We're now up to a value of about 900 and 700 for the not so efficient sensor. So that's a good indication that there's been a change of the dielectric. This is exactly what I was looking for, to maybe set up a system which can monitor the condition of the oil long term using this reference to keep things stable, and look for the change from clean to dirty engine oil. Let's just switch over now to the empty container, which may also be a useful measurement to make. And here we have the empty container. Values have gone right down to zero. This was my calibrated level from the empty container. I wouldn't expect things to change too much there with temperature or anything. And you can see we're right down on zero here. So that's quite another useful measurement which can be made. Capacitor value is exactly where it was before. So this is basically what I hope would be a system for measuring the condition and the presence of oil in an engine, and maybe give a good indication electrically of what's going on.